R5, reviewing radicals. This is page 899, Algebra 2 review in the back of your textbook. Alright, so this is the nth root of a is the same thing as a to the 1 over n, which we kind of talked about the other day. We also talked about this being the nth root of a to the m. Okay, so we talked about those two different things. Okay, so if we think about a couple things, the fourth root of 16 is 2, because 2 times 2 times 2 times 2 is 16. The fourth root of 16 is 2, with the negative out front makes it negative 2. Fourth root of negative 16. I can't take something times itself 4 times to equal a negative number, so we're just going to say it's not real. Okay. The fifth root, we can find the fifth root of a negative number because it's odd, right? And an odd number will be negative. So this would be negative 2 times negative 2 times negative, right? 5 times would equal negative 32. Third root of this is 10, because 10 times 10 times 10 is 1,000. And the sixth root of 6, we can split this into the sixth root of 64 over the sixth root of 729. And 2 to the 6th power, or 2 times 2 times 2 times 2, right? 6 times is 64. And 3 times 3, 6 times gives you 729. Okay, so what we want to do here is we want to convert these to radicals. So you want to put this in radical form. So this would be the third root of 8 squared. Third root of 8 is 2, and 2 squared is 4. Okay, we did a little bit of this in class on Tuesday. This would be the fifth root of negative 32 to the fourth. Fifth root of negative 32 is negative 2. If I take that to the fourth power, I have 16. Okay, remember, if the negative is not inside the parentheses, that stays outside. So we have the fourth root of 16 to the third. Fourth root of 16 is 2, so we have negative 8. That's a 6 right there. So this would be the sixth root of x to the fifth. We're done, can't simplify. Okay, here, this is only, the x is being raised to this power, not the 3, so the 3 stays there, out front. And then it's the third root of x squared. Okay, the 2 is a positive exponent, it's just a 1, so that stays. And this is negative, so it goes to the bottom, and that would be the square root. This would be the fourth root of 3a plus b. Okay, so we also want to go the other way around and convert these to rational exponents. Oh, sorry, you couldn't see that last one. Okay, fourth root, 1/4 is fourth root of that. Okay, so let's convert them. Okay, this would be the same as x to the fifth to the 1/4, so it would be x to the 5/4, right? You multiply those together. Okay, this would be 3y to the 1/2. Another way to write that is 3 to the 1/2 and y to the 1/2. Okay, the 10 is not being raised to this power, but this would be 2 to the 1/5 squared. So this would be 10. I'm sorry, that's not a 2, that's a z. And z to the 2/5. Next one here, 5 stays out front. We have 2x to the 4th to the 1/3 and to the 7th power, which makes that 5 times 2x to the 4th to the 7/3. And then I can take this and distribute it through. This would be 5 times 2 to the 7/3. And we got to multiply these, so that's 28/3. This would be p squared plus q to the 1/2 power. You can't take that through because it's not multiplied. Okay, like here it's multiplied together, so you can take it through. This is adding, so you don't distribute it through. Okay, some other rules here. If they both have the same index, the nth root, we could say it's the nth root of a times b. And we can also kind of separate them. We could say this is the nth root of a over the nth root of b. And the last one here, it's kind of like saying if I have a to the 1 over n and raise that to 1 over m, okay, we, exponent and exponent, you multiply. So it's the same sort of idea here. This is the m times nth root of a. Okay, so think about this as 1 over mn. So it's the mth root of a, mnth root of a. Okay, so if we use those here, these are both square roots, so I can multiply 6 times 54, and that is 324. And the square root of 324 comes up to be 18. Okay, these are both cubed roots, so I can combine them together. M times m squared, which is the cubed root of m to the third, and they cancel out to give you m. Okay, this would be the square root of 7 over the square root of 64. Square root of 7 doesn't simplify, but the square root of 64 is 8. This would be the fourth root of a divided by the fourth root of b to the fourth. That doesn't simplify, so that stays fourth root of a. And this fourth root and fourth cancels to give you b. Okay, thinking about this idea here would be the 21th root of 2. Okay, this is like a square root, right? Implied a 2 there. So it'd be the 8th root of 3. Okay, when we're simplifying radicals, we don't want the radicand to have any factors raised to a power greater than or equal to the index. So we don't want to have, like if it's a square root of x to the fourth, that means we can simplify it if this is bigger than what that is there. The radicand can have no fractions, so we don't want this like square root in the denominator. Denominator has no radical, no square root or cube root there. Yeah, so this one, no fractions within there, because that kind of means there's a radical in the denominator. The exponents index have to have no common factors and all indicated operations performed. Okay, so if we go through these, the square root of 75, if we break that up, it's 25 times 7, and which would be 5 times 5. Okay, so if we think about this, the common, like, simplify this would be 5 square root of 7. Okay, 32, this is, if we simplify it down, 2 and 16, 2 and 8, 2 and 4, and 2 and 2. So there's a group of 5, so the fifth root of 32 is 2. So this is this times 2, which is negative 6. Okay, 288 is 2 times 144. 144 is 12 and 12. Okay, so I have that pair that I need for square root, so it's 12. Think about the m's. M to the fifth is this, so I have 2 pairs, so it'll be m squared. And then inside there's a 2 and a m left over. With 81, we'll say it's 9 times 9. Okay, with cubed root, for looking for things that are multiplied by themselves 3 times, that goes out front. And inside stays another 3 that didn't get used. X to the fifth. Okay, we have one group of 3 that's multiplied together and 2 more left over. Y to the seventh. 2 groups of 3, so y squared, y times y, with 1 y left over inside. And z to the sixth. There are 2 groups of 3, so y squared with no, z squared with no z's left over. Okay. Okay, the other ones down here, we can take this and we can write this as 3 squared to the 1/6, which, and I multiply those together, that would be 3 to the 2/6, and 2/6 is 1/3, so I can rewrite that as the cube root of 3. Whoop, sorry, you couldn't see that. 6th root, combine them together to be 2/6, which is 1/3, which means that's the cubed root of 3. Okay, this would be x to the 12th and y to the 3rd raised to the 1/6 power. If I distribute that through, it'd be x to the 12/6, which is 2, and 3/6, which is 1/2. So I could say this is x squared square root of y. Okay, this is 6 to the 3rd raised to the 1/2 raised to the 1/9. Okay, so if I multiply exponents, it's the same thing as 6 to the 3rd to the 1/18th, and I can even multiply again, and that would be 6 to the 1/6, which gives me the 6th root of 6 is the answer. As we do operations with radicals, we can only add and subtract like radicals. So like these are not alike. That's a square root of 2, that's a square root of 18. Okay, it's sort of like if I add 2x's and 4x's together, I get 6x's, right? Okay, I can add those together because they're both x's. So it's the same idea here. If I have 2 square root of x plus 4 square root of x, I have 6 square root of x. So they have to be alike to be able to add or subtract them. Okay, so here these are both 4th roots of 11pq. So I just add 3 plus -7, which would be -4 of those radicals. Okay, now these are not alike, but we can maybe get them to be alike. So if we think this doesn't simplify, but this one is 9 times 2, which is 3 times 3. So we're looking for a pair for square root. So 3 times 8 is, this would be 24 square root of 2. And then 72 is 9 times 8, which would be 3 and 3, which would be 4 and 2, which would be 2 and 2. So it'd be 3 times 2 is 6. 6 times 4 is 24 square root of 2. So now they're all square root of 2's. I can add them together. Those cancel, so I just have 7 square root of 2. Okay, these here, got to simplify. Let's see, 98 would be 2 and 49. I know 49 is 7 times 7. So this would be 7. And I know it's the square root of 2. And x to the 3rd, if I have 3 x's, square root would be 1x out front and 1 inside. And y stays inside. Okay, 32, maybe 2 and 16. 16 is 4 and 4, so 4 goes out front with the 3. So it'd be 12 x and xy left in the inside. Okay, so notice these are like terms. So I can add the outsides, so it'd be 19x square root of 2xy. So when you add and subtract, simplify to get like terms. Now when you multiply, we have a binomial and a binomial, so you're just going to multiply. That times that is the square root of 16. That times that is -5 square root of 2. Notice that's a number, that's a square root. This would be plus 3 square root of 8 and minus 15. Okay, so we want to simplify stuff. Square root of 16 is 4. That does not simplify. This would be 4 and 2, so square root of 4 is 2 times 3 makes 6 square root of 2. Then we add the like terms. So this minus 15 is -11. Adding the square root of 2's together would be plus 1 square root of 2. You can have the 1 there or not, either way. This times this, square root of 49. This times this, plus the square root of 70, minus the square root of 70, minus the square root of 100. Okay, square root of 7, that's 7, this is 10. Those middle terms cancel out, so 7 minus 10 is -3. Okay, we're multiplying cubed roots, so they're both cubes we can multiply. So this would be the cubed root of 7 times 7 squared would be 7 to the 3rd. That there would be -3 cubed root of 7 squared. And there would be plus 9 cubed root of 7. Multiply this through. Would be 3 cubed root of 7 squared minus 9 cubed root of 7 plus 27. Notice these cancel and these cancel. That's convenient. Cubed root of 7 to the 3rd is just 7. Plus the 27 makes 34. Okay, lastly, when we divide, we had said when we simplify we don't want radicals in the denominator. So we have to get rid of that. So what we can do is multiply by that number. Okay, so square root of 3 times square root of 3. Well, let's do this. Square root of 3 over square root of 3 is 1. If I take something and multiply it by 1, I get the same thing. It's sort of like if I take 1/2 and multiply it by 2 over 2, right? 2 over 2 is 1. I get 2 over 4, which is the same thing, just in a different form. Okay, so when I multiply here, this would be 4 square root of 3 over the square root of 9. And the square root of 9 is 3. So it's called rationalizing the denominator. Okay, so we have got rid of the square root in the denominator. Okay, now with cubed root, I have to multiply by a cubed root, but I'm not going to just multiply by x, because x times x would be x squared, and that won't cancel out. So with cubed root, I need 3 of them, right? Whoops, sorry, I need 3 total. So if I multiply by 2 more, on the top I have 2 cubed root of x to the second, and then down here that'd be the cubed root of x to the third, x and x squared. So that gives me x. So I have that on the top and divided by x. Okay. Now we had also, if you remember back when we did imaginary rationalizing, we multiplied by the conjugate. Okay, we're going to do the same thing here. So this is 1, the conjugate would be 1 plus the square root of 2. So on the top, I have 1 plus the square root of 2. On the bottom, I have 1 times 1 is 1, plus the square root of 2, minus the square root of 2, minus the square root of 4. Okay, notice these two middle terms cancel. Square root of 4 is 2. 1 minus 2 would be negative 1. Okay, and then you could, if you divide by negative 1, you get negative 1 minus the square root of 2. Okay, same thing here. We got 2 terms. We have to multiply by the conjugate, which would be the square root of a plus b plus 1. Okay, so if I take this times this, that would just be a square root of a plus b plus a. This times this would be the square root of a plus b squared, because I'm multiplying it by itself. And this would be plus the square root of a plus b minus the square root of a plus b, so those cancel, and we get minus 1. Okay, so nothing I can do there on the top. Square and square root cancel, so we just have a plus b minus 1. Okay, so those are the notes for R5.